some questions. We are doing some questions on measurement, a very fundamental topic, and this topic comes normally in the start of the paper. So as usual, we will do only few MCQs, but mainly paper 2 questions, selected MCQs. This is March 2021, paper 1-2. You can look at the screen directly. A micrometer screw gauge is used to measure the diameter of a copper wire. The reading with the wire is in position is shown in diagram 1. The wire is removed and the jaws of the micrometer are closed. The new readings is shown in the diagram. What is the diameter of the wire? So you have to read the micrometer screw gauge. What is the diameter of the wire? So first, should I see the diagram 1? What is diagram 2? Does the diagram 2 showing some zero error?
Yes.
Yes. Okay. So let's start reading. Can you read the 2 micrometers? I have read it for you. The left side is 2.5. On the circular scale is 9. So I have obtained this number. The left side is 2.59 minus 0.14. Why minus 0.14?
The zero errors are positive.
Yes. Now see the working. This is a measurement. This is a measurement of zero error. So left side is giving me 2.59. Zero error is coming to be 0.15. How I know? I have to add or minus. It's a positive zero error or negative zero error. My reading has gone above zero. So it's a positive zero error. Positive zero error has to be subtracted and negative zero error has to be added. So this is a good question to recall how to manage. Now I want to do a quick question on uncertainty. Uncertainty is a major topic there. A student measures the current and the PD for a resistor in a circuit. Current is equal to 50.0 plus minus zero point 0.1. Potential difference is 500.0 plus minus zero point 0.1. The measurements are used to calculate the resistance of the resistor. What is the percentage uncertainty in the calculated resistance? The formula is V is equal to IR. So give it a try, quick try.
Sir, for division, do we minus or add uncertainties?
Uncertainties are always added. The formula is V is equal to IR, R is equal to V upon I. Then I wrote the formula and I need a percentage uncertainty. So I will multiply by 100. Uncertainties are always added. So look at the working.
Done, sir.
CRO is another topic which comes sometimes in the paper. CRO is a very rare topic for paper 2. It comes in paper 1 mainly. This is June 2021, paper 1-1. A signal of frequency 25 Hz is displayed on the screen of a CRO. What is the time-based setting? Now you can see the screen and the frequency is 25 Hz. What's the plan? Convert the frequency into time period, then check how much divisions are there in one cycle, and then make the ratio, which is called time-based setting. I repeat, convert the frequency into time period 1 upon f, then see for one cycle how many small divisions are there, and then use the ratio method to see how much for one division. Okay, so if you have done it, you can share the working. I have converted the frequency into time period. Then I convert the second into millisecond, and I'm getting for one cycle 40 milliseconds. So two division for 40. So one division will be 20 millisecond per centimeter. He has defined for 1 centimeter size. This is the working for CRO. It's a very good question to recall how CRO readings are taken. Look at the working and you can solve it also.
Done, sir.
A micrometer screw gauge is used to measure the diameter of a wire. The reading on the micrometer with the jaws closed is this. This is zero error. This is a zero error and it's a negative zero error. The reading with the wire in position between the two jaws is this. What is the diameter of the wire? Remember, uncertainties are always added. The zero error 0.05 is negative, so it should be added. So now you have to see the uncertainty. Uncertainty is always added. It's a negative zero error. So I have added the zero error in my reading. Acha, uncertainties are always added. So it is 1.08 and 0.04.
So why is the 0.02 added?
Because 0.02 is the uncertainty in every reading. So when you are adding the zero error, you have to add the uncertainty also. Uncertainty will be added in uncertainty and normal entry will be added into normal entry.
Mm,
So we have done this thing, and now let's move to our paper 2 question here. Now let us try first this question before moving for paper 2. A student measure the time for one complete oscillation of a pendulum of length L. Her results are shown in the table. She uses the formula to calculate the acceleration of free fall. Find the best estimate for the percentage uncertainty in the value of G. So my formula is T is equal to 2 pi under root L upon G. Please do the working with me. I'm squaring on both sides. It will become 4 pi square L upon G. Then I make G as the subject. And why I'm making it the subject? Because I have to find the value of G. So 4 pi square L upon T squared. This is the formula. Now, percentage uncertainty. So start the uncertainty rule. Deba G upon G, it's a percentage. I'm ignoring 4, I'm ignoring pi square because they are constant. It is Deba L upon L plus 2 times Deba T upon T into 100. Now insert the values, and this will be plus minus Deba L upon L 0.001 upon 0.420 plus 2.1 upon 1.3 into 100. Now, can you solve it, Asad?
yes, sir. One second. Now I'm getting 15.6.
15.6, it means it is approximately 16%.
Yes, sir.
Now look at this question. Define density. June 21, paper 2-1. Please open this paper. This is November 21, paper 2-1. So what is the definition of density? Density is the mass per unit. Density is the mass per unit volume. This is the definition. A smooth pebble made from uniform rock has the shape of an elongated sphere as shown. The length of the pebble is L. The cross-sectional of the is in the plane perpendicular to L is circular with a maximum radius R. A student investigating the density of the rock makes measurement to determine the values of L, R, and mass M. State the name of a measuring instrument suitable for making this measurement of L. L is 0.1242. Look at the number of places. There are 4 decimal places. So you have to refer something very, very precise.
Sir, micrometer, screw gauge, or vernier caliper.
I also, good idea. I also think that a regular apparatus cannot manage it. Obviously, no, it's very difficult for meter rules. So I feel that this is the best option. So micrometer or caliper both can work. So we can write micrometer screw gauge and we can also write meter rule can't be used. So we have to use vernier caliper or we can also use micrometer. Determine the percentage uncertainty in the measurement of R. So can I divide it and make it into 100? Because it's talking about R only. There's no formula given.
Yes.
So percentage uncertainty into R is equal to 0.004 upon 0.0420 into 100. So can you do the calculation for me?
Sir, 0.095.
If you multiply by
Wait
100
one second.
also.
1 second, sir. It's times 0.04. 0. Yes, sir. 0.952.
So it's 0.95%.
Yes, sir.
So now move to the next part. Density of the rock from which the pebble is made is composed given by this. N is an integer and K is a constant with no units. K has no unit. And that is equal to 2.0 with no unit, that is equal to 2.094. The SI units so show that N is equal to -2. So how we tackle this thing? Density is equal to mRn upon KL. He says K is a constant with no units. So should I ignore K?
Yes,
K,
sir.
K has no units, so I ignore K. It will be MRN upon L. I have to show that N is equal to -2. So what I should do, I should try to make R power N the subject. It will be density into L upon M. Can you do till here and tell me what to do now? After that, I have done till here. So what is the unit? R is the radius. So what's the unit of radius? It will be meter power N. The unit of density is kg m minus 3. The unit of L, what is L?
Meters.
And it is kg. So now kg can be cancelled. Then m power n is equal to m power on the other side is -2. So look at the working. Is it clear?
Yes, sir. I finished.
Calculate the percentage uncertainty in rho. Rho means density. Now, this is the title. I have the value of n. I have the value of k, but nn, basically n is the power now. So I can start writing the formula again. Density is equal to mRn upon KL. So should I ignore K again because we are going for percentage uncertainty? So I am writing the approach deba rho upon rho is percentage sign here is equal to plus minus deba m upon m plus n comes behind. Remember, uncertainties are never added. Oh, sorry, never subtracted. Deba r upon r plus deba L upon L, and you should see that where is the letter K? Now, can you tell me the values here? You can help me out. This is, if you can open this side and you can tell me the values. Deba m upon m, Deba m upon m. So Deba m upon m is 0.0001, 0.1242 plus uh, 0.0004, specially note, I'm not taking negative sign of 2. Uncertainties are never subtracted. Uh, I did. Last one is Deba L upon L. Acha, I slipped it. Oh, 0.001 upon 1.072. I made a mistake. I have written M and L swept. So 0.000001 upon 0.1242. I have to repair this entry. The value of L is the value of M 0.001, 0.001, 0.001 upon 1.072. Now, can you make the solution now? This typical calculation, please do it. Yes, Asad, can you do the calculation?
Sir, I got 0.1.
0.1. Acha, I'm getting 2. After multiplying with 100, I'm getting 2. You should check that calculation again. We should move forward. Determine density with its absolute uncertainty. Give your values to the appropriate number of sig fig. Now he says find the density in its real number. So what is density? MRN upon KL. So I'll start this one. Density is equal to MRN upon KL. Acha, the N is equal to -2. What is the value of K? The value of K was 2.094. What
Sir,
is the
can't we just do like the uncertainty of P divided by X times 100 is equal to the percentage uncertainty and then solve it?
this can be done, but we need to find the uncertainty first. I know you're right, but I have to find the absolute value also. Na? Uncertainty wise, you're right. But I said I don't have the value of density itself. So look what
Oh,
I'm not finding the uncertainty. I'm finding the actual value of density. Mass is 1.072. 1.072 kg. What is the value of L? 1.072. Acha, what's the value of 0.1242? 0.1242 meter. And what is the value of R? 0.0420. I have entered all the values and now you have to do this for me, that you have to find the uncertainty. I have put all the values. So put all the values, put the calculation points.
Sir, I got 2336.
2300 after 36.
0.67.
I made it 2337. Still, there are four significant figures. I have to make a justification for the examiner. Should I go for two sig fig or three?
Sir, 3.
Hmm.
More accurate, sir.
I think right now we can keep it like this.
Sir, can I put 2340?
2340 is also fine. I was waiting for the final calculation to come up. Then we can forward, but I agree, you are right. It should be 2340 kilogram per cubic meter. Now, what you were telling me for uncertainty, you can now tell me again.
Sir, I was saying that we can do the uncertainty divided by like the value we have to find, like x times 100, which will be equal to 2, since we found it before.
Percentage uncertainty is equal to uncertainty upon absolute value into 100. Percentage uncertainty was 2. I do not know the absolute uncertainty. Density is 2337 into 100. So I can now round it for this. 2 into 2337 upon 100. So now you can find it.
Sir, 46.74.
And 46. That's coming too big. How uncertainty can be too big?
Sir, he said 2 times 2337 divided by 100.
Acha, what answer you are telling me?
46, sir. I put the exact sum. 2 into 2337 divided by 100.
Hmm.
So because 2 into 2337 will be 4600 something.
So, uh, We're dividing by 100 also, right?
Yes, sir. Otherwise, it would be 4,000 something.
So 2 into 2, 337.
Yes, sir.
Can you use the calculator? I'm getting a different answer. I don't know, but
Sir, 2 into 2,337 is 4,674 divided by 100 is 46.74. Sir, maybe the value of density, sir, may be wrong.
density is looking fine. But this number, so let me check again. Maybe I'm getting. Hmm, I don't know. Okay, overall, can you repeat? Can you repeat your answer? 40.
6.7.
I have made it 50. Why I have made it 50?
Two significant figures.
Because uncertainty should be given correct to how many significant figures?
One.
Uncertainty should always be given correct to one significant figure.
Sir, is it necessary to be whole number?
Uh, Normally, uncertainty is a whole number.
Because they were giving like 0.00004, 0.0001. Done, sir. I wrote.
So that was a good question. We practiced it, and this is a good uncertainty revision. November 21, paper 22, question number 1. November 221, number 202122. Now look at this question. He says complete the table to show the name and symbol of each prefix and the corresponding power of 10. It's a good question, memory question. So look at the table. Look at the first part. I'm just coming in a minute. I have to say namaz. So please look at part A, B, C. I'm just coming. the potential difference V between the two ends of a uniform metal wire is given. I have marked the letters for a particular wire. The percentage uncertainties in the values of some of the above quantities are listed. Look at these percentages. Observe the question.
Yes, sir, I read.
Right. Now look at the working, and the quantities listed in the table have values that are used to calculate rho as 4.1 into 10 power minus 7. For this value of rho, calculate the percentage uncertainty. Look at this. Again, I have shown the working that I have ignored 4 and pi. Look at the percentage working. Now, what is the delta V upon V? Percent is 3.5. We have the percentage directly available. So we can take up the percentage to directly add the percentage. Delta V upon V is 3.5% plus 2 times delta D upon D is 3% plus delta L upon L 2.5% and delta I upon I is 2%. Now, no need to multiply by 100. Can you do this calculation?
Sir, isn't it just 14?
How much? Add all of them, na?
Yes, sir, 14.
14. Okay. The absolute uncertainty. So what would be the absolute uncertainty for what? Calculate for density. So we need to find the absolute uncertainty. So V is equal to 4 rho Li upon pi d square. So how I can find the absolute uncertainty?
Sir, the value of rho is given as 4.1 times 10 to the power minus 7.
Good. So we can use that and we can do the same logic that percentage uncertainty is equal to uncertainty upon density true value into 100. So absolute uncertainty will be, if you take it on the other side and then rho into percentage uncertainty in density upon 100. So then what is the density absolute value is 4.1 10 power minus 7. Rho 1.7. So this is resistivity. 4.1 10 power minus 7. 4.1 10 power minus 7 into 14 upon 100. So do the calculation, please.
Sir, I got 5.74 times 10 to the power minus 8.
5 point. I'm getting something in 6. Can you do your calculation again? I'm getting, Asad, I'm getting, how much you are getting? 5 point?
Sir, 5.74. Yes, sir, I'm
Then,
getting 5.74 times 10 to the power minus 8.
then we can round it for 5.7 into 10 power minus 7. Okay, so we did some paper 2 questions, some paper 1 also. So we are stopping here and we will inshallah continue in our next class. Allah Hafiz.
Allah Hafiz.